So we're finished with Chapter 3, looking at the cables and the media. And now we're moving into Chapter 4 and talking about Ethernet basics. Pause the video for a second and go and open up your book to page 70, and we'll take a look at a couple of graphics that are on a few pages here and relate them to what we're going to talk about. Alright, so on page 70, we're looking at figure 413. I'm zoomed in on it, and what this graphic is supposed to be is one of these Rj45 plugs that you may have previously seen that you find on the end of a cable, right? This is the way that the cable is terminated. It's terminated with a plug. Alright, so this graphic is showing you that the Rj45 plug, and I believe Mike Myers calls it a crimp or a connector, but I refer to it as a plug. So you'll have to make that connection as we go through stuff. Alright, so the Rj45 plug has 8 positions inside of it that allows the whatever is terminated to it to carry 8 discrete signals. Alright, and if you look at the book, they're labeled, the pins are labeled 1 through 8, and you can see that the tab, right, they're trying to illustrate the tab here. Let me bring back the real plug, and you can see the tab that's on the bottom, you know, I would say the bottom of the plug, and then on the top you can see the brass contacts here. Alright, so holding it as I am, the actual plug, the pins or the positions for the wires of 1 through 8 are running from this side over to this side. Alright, so it's important to know which one is which. If I said, you know, contact number 4, pin number 4, you would come to here, and this side, and you would count 1, 2, 3, 4, and whatever, you know, the fourth contact there would be the 4th position. Alright, so you should know that there's 8 positions. They're labeled 1 through 8, and they generally go left to right if you're orienting the plug correctly. Alright, so we have media that we looked at in Chapter 3, the unshielded twisted pair media, which is the most common media used in networks today. It started to be used in 10 base T Ethernet, as you're reading in Chapter 4, and it continues to be used in 100 base T excuse me, and 1000 base T. Alright, now over on page 71 is where we see more information about the media and how things are wired and set up. And figure 415 is showing you the pinouts for the 568A and 568B standards. So on the left is 568A, and on the right is 568B. Now 568A is less used, 568B is more commonly used. But in reality, you can wire a cable, take a piece of media, and put a plug on each end, terminate the ends with a plug, and follow the A standard, and that would work in any Ethernet environment, A or B. It's a hard concept to comprehend sometimes, but it's true that you can use an A or a B in either one of the networks, because that's all about putting certain color codes in a certain position, but the wires themselves go to the same pins. Now hopefully that makes sense, but maybe it doesn't, and don't be alarmed if it doesn't at this point. Alright, so looking at the two standards, can you see anything that stands out at you when it comes to pin 4, 5, and 7 and 8? And if you're looking at the graphic in your book, or looking at this one here, you can see that 4, 5 is the blue pair, and 7 and 8 is the brown pair in both the A and the B standards. Do you agree? But in the A standard, the green pair is on pin 1 and 2, and the orange pair is on 3 and 6. And what are they on the 568B standard? Well, the orange and the green pair are reversed, right? It's the orange-white pair, or the orange pair with the orange-white, right? Orange, orange, white. That's on pin 1 and 2. And the green pair on pins 3 and 6. Okay. So, if we take a look at a couple of cables now, I'm going to slide the book out of the way and zoom back out and look at a couple of cables. Right, I've got cable A and cable B, and to the naked eye, as they say in, I don't know, some TV shows, you would see they would look very similar to each other. If I bring the cable up closer, where we can perhaps see some of the labeling that's on here, can we make out that this is a category 5 cable? All right, and then this one over here, same thing, take a look at it, and lo and behold, we're looking at a category 5 cable. Both of these cables came from the same box of cable, so they're perfectly the same. They might have been pulled out, cut, and then the other piece pulled out and cut. All right, but these two cables differ from each other quite a bit in the way that they're terminated. So this cable, I know, is a straight through cable. And what exactly does that mean? Well, a straight through cable is one, if I come back to the book, a straight through cable is one that is wired to either the A standard on both ends or the B standard on both ends. So if we could look at this cable up close and make things out, I don't know how well the camera will focus on it, but it seems to be a B standard because I see the orange wire in the 1 and 2 position. So I'm going to go out on a limb and say this is a B standard wire, right? And you can tell that by looking at it. Now, I'm going to come in here with my, zoom back out again, come in here with my network tester, and you'll learn how to use these testers in no time at all. And I'm going to connect my remote unit and my main unit to the cable, and then I'm going to hit the data button and do a quick test. And what I should see are the pinout connections between the far end and the near end. So you can see the numbers 1 through 8, and then right underneath it you can see another set of numbers 1 through 8. All right, what that means is on one end, pin 1 is connected to pin 1 on the far end, and 2 is connected to 2, and 3 is to 3, and so forth. So this cable goes straight through. What is on 1 goes to 1, 2 goes to 2, and so forth. So if it's following the B standard, as we suspect, then that means that the orange-white wire is on pin 1 on one end, and it goes to pin 1 on the far end. And the solid orange wire is on pin 2 on one end, and it goes to pin 2 on the far end. And that pattern continues all the way down. All right, so when I wire something to, when I wire a cable, piece of media, to that standard, I have created a straight through patch cord. Now what I find over the years is that people will call these things by different names. Some of the names are not very accurate, right, in a purely academic sense, I guess. This cable being wired to 568 B on both ends, or it could have been A both ends, is an Ethernet patch cord. It's an Ethernet patch cord. It's made to connect a computer to a device. It could be a hub or a switch, right? Generally it plugs into the wall or something, but it is the type of patch cord that would be used to connect a typical node to the network. All right, the one that's mostly in use today. If you walk into a classroom in the school, walk into an office, it's got computers connected, and you look down and you see the media, you look down, you see the media, you see the patch cord. You're looking probably at an Ethernet patch cord, a straight through cord that's wired to either the A or the B standard. All right, so the other patch cord, now I'll get this out of here. And I'll bring this one in, and if you've been looking at it, you probably notice I got this label thing on it, and I do this in the classroom to help folks to understand what's going on. You can see pretty clearly this is labeled crossover, but in the real world you're not going to have labels on cables that are telling you crossover, straight through, or whatever. So you have to be able to look at it and tell. Now with the tester, that's quite easy. Right? We come along, we take our tester, and we connect it up to the main unit, connect it up to the remote unit, and we run our test, and we come up with the wire map, and we see this. 1, 2, 3, 4, 5, 6, 7, 8 on one end, 3, 6, 1, 4, 5, 2, 7, 8. Boy, that looks pretty messed up, doesn't it? All right, well, there's a reason for that. And the reason is we're looking at a crossover cable. So the crossover cable is built and it's used for certain things. It does have a place. How do you make a crossover cable? Easy question. You wire a cable, you terminate a cable by putting the plug on one end following the 568A standard. And on the other end, you wire it to 568B standard. And by doing that, can you see where what's on pin 1 and 2 on one end is going to go over to pin 3 and 6 on the opposite end? And what's on 3 and 6 on one end is going to go to 1 and 2 at the opposite end. Sometimes that's a hard thing to see. So if you flip over in your book to page 75 and you take a look at the top of the page, you have this graphic 423. That's exactly what this graphic is showing you, that how a crossover cable is created, and by putting A on one end, B on the other, and in doing so you are reversing or let's just say we're reversing the transmit and receive pairs. And if you follow the colors out in the graphic, right, from the A side to the B side, you'll see the 1, 2 over here going to 3, 6 on this side, and the 3, 6 on this side going over here to 1, 2. So this one shows it to you with the color codes, and that's what that graphic is all about there. All right, so if we go back to the tester and we were to look at it again and we compared it to what we see on the book, whoop, holding that baby too close, aren't I? All right, you see it with what's in the book, and you can now hopefully make the connection between the graphic in the book and what you're seeing on the tester here, and more importantly, that you're seeing a crossover cable and seeing how it will show up on a tester, and which some testers will report it as being a bad cable, failing test because it doesn't go straight through. But in reality, it's not a bad cable because it's wired differently, and it's wired differently so it can perform a certain role. And that certain role is something that we will talk about in an upcoming video. I just wanted you to see on this video how it's constructed, what it looks like on the tester, and kind of make a connection between the book pages, right, the figures and reading in the book, and the items in real life. Right, so I hope that this was helpful in your understanding.